All right, on to a new unit. Okay, we're looking at the essential question of why do things move? Okay, last time we talked about how do things move. This time we're looking at why. Okay, why do things move? What are the underlying principles of movement? What causes things to move or not move or change their motion? Okay, and we're going to do part one right now, which is Newton's first law. You've probably heard it before, but I want to go over some key things now that you're out of middle school and out of elementary school. There are some more nuances that you need to learn. It's not as simple as what you might remember. Okay? But we need to talk about Sir Isaac Newton. Genius, basically. He was born in 1642. He died in 1727. He was actually born on Christmas Day, which is very, very interesting. He's from England. But he's really big. He is a really big genius, but he is most widely known for physics and probably most for his laws of motion. But he's got a lot more to him than just the three laws. Okay, he is most famous for this publication, the Philosophiae Naturalis Principia Mathematica. Let's abbreviate that. Okay, most people just refer to it as the Principia. Okay, you definitely want to write that down. That's something that he did, and it's not this whole book. It's part of this book, and it's really interesting stuff if you are a giant nerd like me and appreciate reading stuff like this. Okay, it is really neat, but you guys probably won't look at it anyway. Now, in this book that he published his works. It actually took him a while to publish it. He didn't want to publish it because he wasn't very confident in himself, I guess you could say. And it took the Edmund Halley, somebody who knew him and talked to him for a little bit. Edmund Halley noticed that he had discovered things like gravity and such, and said, "Newton, you really need to publish this. Like, this is good work. Please publish it." And Newton was, I guess, scared or whatever, but you can find more about that online. But bottom line is, the biggest things in the Principia are the three laws of motion and the universal law of gravitation. That's what we're going to study in this unit. These four things really are the laws that govern why things move or why things change their motion. Okay? But that wasn't it. He was really into optics, okay? Meaning anything that has to deal with light. You've seen him sometimes with a prism. He looked at how white light is actually a combination of all the different colors of light. He also built a new kind of telescope. Most telescopes back in the day were a lens, okay, that fed down to an eyepiece right about here, okay? And there was a lens here. But he figured out here that if you put a mirror down here and change the eyepiece up here, the light would come in, it would bounce off of the mirror, come back up, hit another mirror here, and come out here. It was a better telescope, and we still use them today. Also, he was hugely into math. He basically invented calculus, which is really big. And his other, I guess, hobbies, or at least things he wasn't as well known for, would be alchemy, which is trying to make gold out of other materials, which doesn't really, work, but it was an interesting thing for him to do. And also theology. He was a very deeply religious man. He, I guess that's really all I can say about that. He was just very, very religious, and he did good science. So keep that in mind. You can be religious and do good science. Okay? Now that's a little bit about Isaac Newton. Let's talk about his law and what it actually means to us. Okay, Newton's first law. This is not the way it's stated, okay, in the Principia. Okay, in fact, I probably should look at it, but it's probably in Latin or whatever. But here's the easiest way to think about it. Okay, an object's velocity will remain constant unless the object is acted upon by a net force. Okay? So there's the key thing here is that the velocity will remain constant unless you have a net force. Okay? So the velocity will remain constant unless you have what's called a net force, or just a force, really. Okay? That's the easiest way to think about it. Now, when we say velocity will remain constant. If something's standing still, that is a constant velocity. Like if I have my water bottle here, okay, that is a constant velocity of 0, okay? And that's going to remain there. It's going to remain at that same velocity unless it's acted upon by a force, okay? And then it will keep going, all right? Now, friction slows it down, obviously. But the idea here is that if this were in motion, let's say it was a bowling ball rolling, it would keep rolling at that same speed, assuming there's no friction. It would keep rolling at that same speed unless a force came by and slowed it down, or sped it up. Maybe it hit a bowling ball and the force interactions in that slowed it down, or it hit a wall, or somebody put their foot in front of it. I don't know. But exerted a force and changed the motion. Okay? Now, the way that you've normally thought about it is probably this way, which is that an object at rest tends to stay at rest. That would be the water bottle staying there. An object in motion tends to stay in motion. Think of a bowling ball. Okay? Unless, there's no 3 L's in there, unless an unbalanced force acts on it. Okay? So, there's 3 parts to this. All right? One part is that an object at rest tends to stay at rest. Okay? So the velocity will stay 0 all the time. Okay? Or an object in motion tends to stay in motion. Okay? That's when the velocity is greater than 0, or actually could be less than 0. Maybe it's in a negative direction. But it has a velocity, but it's going to stay moving. Okay? A bowling ball is moving in a direction. It has a certain velocity. I don't know, 2 meters per second? I don't know. But anyway, the idea is that it will stay in motion. Okay? Unless, and that's a key word here, unless an unbalanced force acts upon it. So, what it's saying is that the thing at rest will stay at rest unless a force acts on it. So the water bottle is going to stay here unless something hits it or moves it or whatever. Okay? An object in motion tends to stay in motion, so the bowling ball will continue until an unbalanced force acts upon it. And what do I mean by an unbalanced force? Well, let's say you're on a skateboard. Okay? See, there you are. And you're going at a certain velocity. Okay? Let's say you have a velocity of, I don't know, 2 meters per second, okay? But let's say somebody tries to slow you down and exerts a force in that direction. But you also have a buddy who's trying to speed you up, and he exerts a force in that direction. Let's say they're the same force. The person's pushing you back is exactly as strong as the person's pushing you forward. They cancel out. It's a balanced force, okay? And so what happens is you keep going at your same speed. Another way to look at this is, again, the water bottle. Okay? Right now, there's a force of gravity pulling it down. But my hand is pulling it up. Those are perfectly balanced forces, and therefore, it's not moving. Okay? All right, let's move on. That might be a bit much of explanation there, but let's move on. Okay? All right, so this is also known as the law of inertia, okay? And that's key. Inertia is very, very key here. Inertia is kind of a tough concept to understand, but the idea is that inertia is an object's resistance to changes in motion. So it's not a force. In fact, I'm going to write that really big here, okay? Inertia, and you need to write this really big in your notes. Not a force, okay? Inertia is not a force. It's just the idea that objects resist changes in motion, okay? If I want to move this water bottle, I have to exert a force. If this water bottle is completely full, I have to exert a bigger force because it has more inertia, okay? So it's a resistance to changes in motion, okay? So here's the thing. In order to speed this up to 2 meters per second, it takes just as much force or just as much energy as it does to slow it down from 2 meters a second to a stop, okay? Because it has a resistance to changes in motion. If this is in motion, I've got to push on it, overcome that resistance to stop it. And if it is already stopped, I have to get over that initial velocity of nothing. I've got to push it and change its motion. It's got kind of a resistance to it. Now, the thing is that the more mass this has, the more inertia it has as well. Okay? So it's just like saying that inertia is an object's resistance to acceleration. Okay? Basically, things want to keep going the way that they're going. Just going to keep doing what they're doing. Okay? They resist change in motion. They resist acceleration. In order to change something's motion, you need a force. Okay? All right. Might be going too into depth into these. But last thing I wanted to encourage you to do is watch Julius Sumner Miller on YouTube. He's got some great examples of this. Does a better job than I could do, at least in the limited time. But go ahead, watch that. It's going to help you out. But let's keep in mind, both of these should be in your notes. This is the more clear way of saying it. Well, actually, some people might think this is a clearer way of saying it. Depends on how you look at it. Okay? But all objects have inertia. It's not a force. Okay? It's the idea that they want to keep doing what they're doing. And in order to overcome that inertia, in order to change its motion, you need a force. Okay? So to overcome inertia, you need a force. To change the velocity, you need a force. And that's this unbalanced force here. Okay? If you have any questions, make sure you ask them in class, and I'll see you tomorrow.